now we have some pure acid, right? Like we have a beaker of pure acid, and we're going to add that to a beaker that's a 5% solution. And what we want to get out at the end is 95 liters of a 55% solution. Let's draw a picture of what we've got. Here's how I see this. We've got a beaker. We've got a beaker here, and this is how much? What do we have? This is let's see. This is the pure acid. All right. So this is pure. Now, a pure acid, I'm going to put the percentage of acid outside as a descriptor. So this is 100%. Now, that's just going to be a 1 because I'm going to do it in decimal. So 100% is a 1. That's 100% acid. And how much? We don't know. How about if we let that be X? Then what we're going to do is we're going to pour this into this other beaker that is, okay, we're given that this is a 5% solution. So this will be 0.05. And how much? We don't know because that's the question. What amounts of each? Well, let X be the amount of the 100% solution, the pure acid, and let Y be the amount of the 5% solution. And that we get out of that is a beaker, probably a little bit more of what? Here's we are. We know we have 25 liters, so that's inside, right? Inside we have 25 liters, 95 liters of what? Of 55% solution. Now, here's an equation right away. The equation is this. I got 100% of this plus 5% of that gives me 55% acid of this. So here's one equation here. X plus 0.05 Y, and that's equal to 0.55 times 95. But now we have two variables here, so we need another equation. And I think we can get another equation just by looking at what we have here. Actually, what is this one? This is the amount of acid, right? I got 100% acid plus, now 5% of this amount is acid, so I've got acid here, and that gives me 55% of this, which is acid. So this is measuring the amount of acid. Now, if I just measure the amount of solution, it's this amount plus this amount gives me that amount. So here's another equation. I have two variables. I need two equations. X plus Y, that's equal to 95. There's our equations. Let's call the top one 1, the bottom one 2. So let's solve this system. Now we have two methods, elimination by substitution and elimination by addition. I think I'm going to use substitution for this one because it's pretty simple to solve for X and Y, X or Y, without getting any fractions. And you can probably hear my cat agrees. So I think what I'm going to do here is I'm going to solve equation 2 for, doesn't matter, pick one, X. So if I solve it for X, I'm going to subtract Y, and I will get X equals negative Y plus 95. And then I'm going to take this negative Y plus 95 and substitute that into X in that first equation. Now doing so will give us that X, but that's going to be negative Y plus 95, and then plus 0.05 Y, that's equal to 0.55 times 95. So let's combine some like terms here. We have negative 1Y plus 0.05. You know, what I'm thinking is this. I got negative 1 plus 0.05Y. That's going to give us negative 0.95Y plus that 95, and that's equal to, now, 0.55 times 95 is 52.25. 52.25. Let's subtract that 95. So now we are at negative 0.95 equals negative 42.75, 95y, right? And now we're going to divide by that negative 0.95. So I will do that, and I got 45. So y is equal to 45. Now, we can get the other one pretty easily, because what do we know here? We know that from this second equation, well, why don't we just come back down here? What do we have? X is equal to negative y plus 95. So what do we get for x now? So x is equal to negative y. Y is 45, right? We just found it. So y is negative 45 plus 95. So x is equal to, you've got it, 50. So let's write our answer. Let's summarize. So how much of the pure acid and how much of the 5% solution should we use? Well, let's go back here and find out what the pure was. The pure was this one over here, right? That was x. So x is 50. So we need 50 liters of the pure. And then the y, that was the 5%. The y we found to be 45. So we're going to have 45 liters of the 5% solution.